Okay, so we need to restrict this so that it's 1 to 1. If a function's 1 to 1, it means it passes the horizontal line test. It only touches the horizontal line once. So if I was to draw a horizontal line straight across at y equals 5, it would cross here and it would cross there. So it fails the vertical line, the horizontal line test. So if we restrict it from -8 to -3, that would do it, because that means we only consider the graph between x equals -8 and x equals -3. We cut off this whole other side, and if you imagine that whole other side gone, then it passes the 1 to 1 test everywhere. From -6 to +2, we still have that triangle, so we're still going to have a horizontal line between those values. That would not pass the horizontal line test. From -5 to 0, we still have a triangle. That would not pass the horizontal line test. -5 to -1, that still makes a triangle. -3 to 2, so -3 in the x to +2 in the y. So -3 starting here, draw the line down to x equals 2. And forget about this side. That is 1 to 1, because the graph only crosses one spot in any horizontal line you can draw. So from -3 to 2, that works. And -6 to -1, start at -6, end at -1. That graph looks like this, so it would fail the horizontal line test up here, right? So forget that one. So here's f of x. We're supposed to plot the inverse. So the big thing you should be thinking about is that the inverse has the x and y's switched. So in our new graph, we should have 3 on the x, 0 on the y. Because for the graph of f of x, let me see if I can make my pen bigger. There we go. So for this graph, it crosses at 0, 3, right, on f of x. That's a dot that's on the graph. So the inverse needs to have inverse of x needs to have 3, 0. I switched the x's and y's, which is what an inverse does. So let's see if that helps us eliminate. 3, 0. This purple line does not cross. This is not the correct answer. 3, 0. Oh, that's close. Yeah, but I'm pretty sure 3, 0 has to be there, so that doesn't work either. 3, 0, no. 3, 0, no. This is the only one that crosses at 3, 0. So by process of elimination, that's got to be the last one. Okay, but you could do that for an infinite amount of points. Asked to find the inverse of this. I'm going to post a video for this one because this one will take longer. It's pretty tricky, but I'll post a video for this in a bit. You got to switch x and y, so you got to put y's up here, x over here, and then you got to solve for y again. It does take a bit. Wow, so I don't understand Newton sometimes. That one up there takes a while. They're showing you the steps. It's not easy. This one down here is much easier. This is like your y value. This is your x value. So you switch the x's and y's. So if a student got that top one right, why on earth would you want to check them if they know how to get this one? So subtract 8 from both sides. So you get x minus 8 equals -10y. And then you want to divide -10 from everything to finish getting y by itself. So you get y equals negative x over 10 here. And then this is -8 divided by -10. That's a positive 4/5. So let's see, -x over 10 plus 4/5. I think that's our winner. Okay, so the same steps of that other one that I skipped. It's just going to take a lot longer. So we're supposed to draw the plot of y equals the inverse. So let's do the same thing. The purple line is the original graph. That crosses, just like the last one, at 0, 3. That means the inverse needs to cross at 3, 0. So let's draw one of these at 3 on the x, 0 on the y. So there's one dot. Now let's try to find another dot in this graph. It looks to cross at -1 on the x, 1 on the y. So -1 on the x, 1 on the y for the original function. That means the inverse should cross at 1 on the x, -1 for the y. 1 on the x, -1 for the y. That's the graph of the inverse. And the inverse should always be making a mirror image around this diagonal dotted line, the y equals x line, which ours does. Oh, it stops here. Okay. So they want, I mean, there's an infinite amount of intervals. Oh, they want all of them. Okay. So we've got two sides. This fails the horizontal line test if we include everything. But if we start at x equals -1, and then if we end at x equals 3, then it would have an inverse because that graph would look like this. It stops right when it starts changing directions. Passes the horizontal line test everywhere. I think they might want brackets though. I can't tell. Let's try parentheses because parentheses means you don't include. And then same thing on the other side. Start on x equals 3 and then we end on x equals 7. They should draw a solid dot here. I think they want brackets in the end. Either way, they'll show us the correct answer. And I can, here, let's just do this. They want brackets for both. Okay, 3 comma 7 or -1. 3 comma 7, we got that one. -1 comma 3. They just switched the order. Either one should be okay. You should get it right if you were to write it in the other order too. But brackets for that last one. Okay, this one doesn't take too long. That last one I showed you is the toughest one you'll see. That's why I have a bunch of separate videos for that one. So we're asked to find the inverse, so we'll switch x and y. And then we will solve for y. So subtract that 4 from both sides. Divide both sides by 7. And then we need to take a square root to cancel out a squared, right? To finish solving for y. And that's positive or negative. Every time we use a square root to cancel out this squared, we got to use a positive or negative. I square rooted this to make it just be y, but you have to use the plus or minus sign. Now, which one do we type in? The plus, the minus, both? And the rationale is going to come from over here. X is greater than or equal to 0, right? Inverses have their x and y values switched. So for our inverse, y should be greater than or equal to 0. Okay. So for that to happen, we got to exclude the negative possibility because that would be a negative value. That would be y less than 0. So the correct answer for this one is x minus 4 over 7 underneath the square root like this. Oops. X minus 4 over 7. So it's x minus 4 over 7, just like that. Okay, that's the same one. Just different numbers. Oh, this one's tougher. I think I could probably fit this in a short little video. So we got to find the inverse. So I'll switch my x's and y's. And then I'll solve for y. So I'm going to subtract that 6 from both sides. I'm going to divide that 4 from both sides. To get rid of the square root, I got to square both sides. But when you square both sides, you don't have to worry about the plus or negative. And then the last step is to subtract that 2 from both sides. So that's our inverse. Oops. I'm putting that in parentheses, that way I can get a fraction by typing. So we've got to wrap the whole thing in an exponent. And minus 2. I think we got it. Okay, that one's similar. Don't you wish you had that button? Yeah, we've already done something like that. Alright, we've already done something like this. Already done something like this. I think that might be all the weird stuff. Okay, that one, it's going to take longer. I'll have videos for that one. That one's easier. I have no idea why. I think they have those reversed. And then we've done this one. Okay.